In this unit, we're going to learn a lot about the periodic table and how the periodic table is organized. So, periodic law says that when you put elements in order by increasing atomic number, there's this periodic repetition of physical and chemical properties. Our periodic table now is organized by increasing atomic number. However, when it was first arranged by Mendeleev, it was put in order based on chemical properties of different elements as well as the mass number. So in the periodic table now, we have these horizontal rows, and the rows we call periods, and there are 7 different periods. And we know from the last unit when we talked about electron configurations that the period actually correlates to the number of energy levels. Then we have columns of the periodic table. The columns of the periodic table are called groups or families. And things that are in columns with one another share similar physical properties as well as chemical properties, and we give them numbers as well. So there is a system of numbering the periodic table in which we have groups 1A, 2A, 3A, all the way through 8A, and then we have 3B, which are all the transition metals. Okay, so first we divide the periodic table in 3 different classes, 3 different sections: the metals, the nonmetals, and the metalloids. All metals share similar properties. They are electrical conductors. They can also conduct heat. They have luster, which means they're shiny. They're ductile, which means they can be stretched out into wires. And they're malleable, which means they can be hammered into different shapes without bending. Now, metalloids are really, or nonmetals are really the opposite, right? They're generally pretty brittle, so if we tried to hammer them, they'd shatter. They're not shiny, or they're non-lustrous, we say, and they're poor conductors of heat and electricity. Then we have several elements that are called metalloids, and they fall along this stair-step line. So I've drawn it in on this periodic table. You should see it on your own periodic table. And this group is the metalloids, okay? And metalloids sort of have these intermediate properties. They kind of fall along this line between metals, which are all on the left-hand side of the periodic table, to the left hand of the stair-step line, including these lanthanides and actinides under here. And then up here in the right-hand corner, we have all the nonmetals. And so there are several metalloids that kind of fall along this line that sort of share properties with both metals and nonmetals. Okay, so on the periodic table, just as a review, we know that we have our boxes, and within the boxes we have an individual element with an element symbol, an element name, an atomic number that tells us the number of protons, an atomic mass, which gives us the average mass of the isotopes that we find on the planet. And on some periodic tables, we actually get electrons in each energy level. So it essentially gives us the electron configuration. The periodic table that you have in your reference tables doesn't include this, but we now know from the last unit how to figure that out. Okay, so certain groups in the periodic table have special names or family names. Group 1A are called alkali metals. The reason why they're called alkali metals is because alkali is another way of saying base, or the opposite of acidic on the pH scale. So alkali metals, when they react with water, they form a base, and they're highly reactive. So when we put them with water, they react. And in nature, we don't really find them unless they're in a compound that they have reacted with water to form. Group 2A are called the alkaline earth metals. They also form bases when they react with water, but they're not quite as reactive. They don't dissolve well, which is why we call them earth metals. So we typically find them in their solid form in the earth, rather than like the alkaline metals, ones that have already reacted with water. Okay. Group 3B is set low. That's a big group, and I'll point it out in a minute here when we actually look at sort of a diagram of the periodic table. Those are all transition metals. We sort of set them aside. And then we have other columns, and group 7A, the 7th column, we call halogens. The prefix halo means salt. So halogens are salt formers, which we'll find out what that means here a little bit later in the unit when we start talking about ionic bonds and the formation of ionic bonds. The last group that has a specific name are the noble gases, and they're group 8A, or they're group 18 sometimes called. They're the farthest right group on the periodic table. They used to be called inert gases. They're very, very stable, and they typically do not react. And the reason why is because that elements react in order to fill their S and P sublevels. Okay, so when an S and P sublevel becomes full, it's when the element becomes stable. So noble gases already have S and P sublevels completely full, so they're not as likely to react with other atoms. Alright, so let's take a look at it on the periodic table. We have this pink group here, so that's group 1A. These are all the alkali metals. Hydrogen is an exception. Hydrogen is not considered an alkali metal. Then we have group 2A. These are the alkaline earth metals, okay, here in green. And like I said, we have this group that's sort of set aside from the others. So all of the white are transition metals. So all of these, including the lanthanide and the actinide series. These groups right here, this is group 3, 4, 5, and 6, they don't really get specific names because recall that our stair-step line kind of falls right here. And so we've got sort of this mixture of both metals and nonmetals and metalloids going on. Then we have the light blue, well, let's get back. Group 8A, we have the noble gases, so these are all ones that have the S and P sublevels full, and then 7A are the halogens, okay? So just keep in mind the names of those specific groups. And lastly, I just want to mention again that remember we also have the numbered rows of the periodic table, also called periods. And this number correlates to the number of energy levels, which we should know from the electron configurations, okay, that we did in the last unit. The next videos we're going to talk more specifically about specific trends within each of the groups and periods of the periodic table.